So the first thing we're going to do, we looked at integrating with polynomials yesterday, and remember that integrating is just the reverse of a derivative. We all good on that? I'll do a couple of practices. I don't expect that we're going to be awesome at that yet, but I thought we'd introduce some new rules so we could do some practice with a whole bunch of them together. What's the derivative of e to the 4x? 4e 4x. So what do we think the integral of e to the 4x would be? E to the 4x divided by 4. Does that make sense?
I'll see.
Very good. And the snarky voice too, I like it. So we can see a pattern there, can't we? If we were to have 4e to the 4x, we'd expect to get back to that line there, wouldn't we? And that's how we knew we had to divide by 4. Sine, what's sine of 2x? Derivative of that? 2 cos 2x. Now, I've made your life nice and easy here. If I was to integrate that, what should it go back to? So if I was to integrate this, it should go back to that, correct? So if I'm going to integrate 2 cos 2x, it must become sine 2x. I'm going to give us some rules in a second. We're going to make our own rules up after doing this. The last one, I've got cos 6x. What does the derivative of cos 6x equal?
Negative 6 sine.
Negative 6 sine 6x. I haven't been as fine with this next one. What do we think the integral's going to be? Not snarky enough. Very good. Very good. Okay, you're too polite. You guys are classy. What do I need to do? What do we think the integral of sine 6x is going to be?
Negative cos 6x on 6.
Negative cos 6x on 6. Who agrees with James?
Oh.
Max is like, that's a wise way to live your life. He's right. Okay. So we're going to make some rules up. We've sort of got our head around what's happening. We probably haven't formalised it with a rule. So I'm going to give us a rule. I'm not going to give us a rule. I'm going to exponentials. And these are not how they come in the formula sheet, but it's how they should come. So if I've got the function and now you've got an example, hopefully we can see. If I've got y equals the integration of e to the fx, that needs to become what? Just let them figure it out. Now, I'm of the belief this is how they should come, but it's not how they come on your formula sheet. But it's one of those things where if you need to look at it, you probably haven't done enough practice. Girls in the front row, you're excused because you weren't here yesterday. That's my only. But Max, what do you think the rule is for the exponential? Power. So it should be e to the, what order the e to? Leave it?
Yeah.
So it's e to the power of fx still?
Plus 1.
Do I plus 1?
Oh, no.
No, I'll leave it as it is. That's the power of an exponential. The derivative stays exactly the same. So the integration, vice versa. What do we do to the, you said something about divided by?
Yeah.
The power, so it's fx. Do we agree with that? I'm getting some shaking. Well, let's just check out. Is this the correct integration or not? So that's it. fx would be 4x here, wouldn't it? So should it be divided by fx? Yeah, so if I had y equals e to the power of fx, dy dx becomes what? F dash x e to the power of fx, correct? So what do we think we need to do to undo that? We should be dividing by f dash x. Does that make sense? Divide by the derivative of the power. So if the power was x squared, we divide by 2x. Cool? Oh, we're going to compare this to what they've got in your formula sheet soon, but it is really, if I was taking notes on a few things this year, to be one of the things I'd take note of. Because it's a much better representation, much more useful than what you get in the formula sheet. So when we integrate cos, the first thing we need to identify is what does sine become? Regardless, don't worry about the sign, what the plus or minus sign, not the sign. Don't worry about the plus or minus sign. What does sine become? A cos function, right? We know it becomes, so I always go cos. And then I'm like, well, now I think about it as a plus or minus cos. Minus? You can either remember that off by heart, or I like to think about the fact that derivatives, I can visualize derivatives. So when I think about a sine graph, looking like this, right? Where does the derivative go initially? Positive or negative? Positive, so I can see that it becomes positive cos, which means the integration's got to be the reverse of that. So I always go, derivative, is it positive or negative? If it's integrating, I'm doing the other one.
Will it always be negative cos? Will it always be negative cos?
Yeah, always be negative cos. Now that is in your formula sheet. So that is the one part that helps, because that's the part you're going to forget. Is it, you will be sitting on as a plus or minus, I can't remember, whip your formula sheet out. That'll tell you whether it's plus or minus. The minus is there, but it's not actually very useful apart from that. So what happens to the function? Does it stay the same inside the brackets, or do we change it? Stays the same, as per all of our things, all of our rules. Done? No, what have I got to do? Divide by f dash x. Common theme, isn't there? Divide by the derivative. Divide by the derivative, we're all good. Cos becomes? Sine. Positive or negative? Positive, again, we use that integration. The derivative for cos is negative, so it must be the other way around. The derivative of cos becomes negative sine, so we know that the integration of cos must become positive sine. Cool?
What does C mean?
We'll get to that. Just write plus C and be snarky at this point in time. So it's positive sine, what happens to the function inside? Yeah, thankfully most of our rules apply exactly the same for cos as they do for sine. Cool? Do we understand that? And that's used for finding an area under the curve. We're going to do definite integrals first, soon, but at this point in time it's just really important we understand the rules so we can work through those. Happy with that? I will set some work, but I'll give you 10 minutes to do your education perfect so you get your head around that and you can ask for help now rather than doing it at home.